Alright, hello, I am Matthew Anderson, and today I will be going over a calculus problem with you. So, Grant goes on a 10-minute drive in his gas-efficient car. He knows that at t equals 7, where t equals time in minutes, the instantaneous rate of change, which is another way of saying the derivative, was negative 289 milliliters of gas per minute. He also knows that at any time t, g double prime of t equals negative 6t minus 18, where g double prime of t equals the derivative of the instantaneous rate of change, which is another way of saying the second derivative, of the amount of gas. Grant also knows that at t equals 7, there was 1,208 milliliters of gas left before the gasoline meter broke. He wants to know the amount of gasoline in milliliters that Grant has remaining at t equals 9 minutes. So I went ahead and wrote this out into several parts because this is very complicated. First we have find the first derivative with that initial condition, and we know that the second derivative is negative 6t minus 18. Then after that, find the original equation with the initial condition of g of 7 equals 1,208 milliliters of gas. Then after that, the last step is to find the actual amount of gasoline left at 9 minutes. Alright, so let's get started. First off, we have to take the integral here. So it's going to be, sorry about the shaky by the way, negative 6t minus 18 dt. Alright. That comes out to negative 3t squared minus 18 t plus c. Now we need to plug in the initial condition to find out what that c value is. So at g prime of 7, that is equal to negative 289, which is equal to the equation that I just found, negative 3, 7, plugging in the 7s for where the t's would be, minus 18 times 7 plus c. That comes out. Simplify that a little bit now. Negative 289 equals negative 147 minus 126 plus c. I'm going to switch that around. So when I add these together, it comes out to negative 273. C minus 273 equals negative 289. So I add that, and it comes out to the constant equals negative 16. Okay? So then just to rewrite that, g prime of t equals negative 3t squared minus 18t minus 16. Next step, part B. We have to find the original equation g of t at g of 7. First step again, take the integral of what we just found, which is negative 3t squared minus 18t minus 16, and then after that it comes out to negative t cubed, because that becomes a 3, just divides out, minus 9t squared minus 16t plus c. Next step, as before, use the initial condition to find c. So g of 7 equals negative 7 cubed minus 9, 7 squared minus 16 times 7, running out of room here, plus C. Oops, sorry. And that is equal to 1,208. Alright, so 1,208 milliliters of gas per minute. Keep in mind the units. Oh, 1,200 milliliters of gas, I mean. This comes out to negative 343. And that comes out to negative 441 minus 112 when you negative 16 times 7 and plus C. Simplify that all together. I did this in a few steps, so it's a really complicated one. 1,208 is equal to negative 784 minus 112 plus C. Now, simplify that again. This is almost the last step there. And that comes out to C equals 2,104. On to the last part, which is what we actually want to know. Remember that Grant wants to find how much gas he has remaining at t equals 9 minutes. So this is the probably the easiest step here. Just plug in 9 into that equation that I didn't write like I should have. Okay, equals t cubed minus 9t squared minus 16t plus c plus 2,104. I mean, you didn't hear C. Alright, now to plug in that. Negative 9 cubed minus 9 squared, same thing, minus 16 times 9 plus 2,104. And this is a annoying thing to crunch in your head. We have negative 729 minus 729 minus 144 plus 2104. And then once that is simplified, that equals 502 milliliters of gas. So at t equals 9, Grant has 502 milliliters of gas left. That's it. That was calculus.